Okay, so I'm on live and I'm sharing my screen to you. Okay, so this is, so in the downside it is chapter 7 and on we will see part 6. So today's is part 7. So part 7 is live session is already running and I'm using different application today, but I want to try the new application. Okay, so this is my new application. Oh, just give me a second. Yeah, it's become full task. Okay. So we solved some problems in the last class. Screen is not very clear. Yeah. I think in the last class we completed the 7th. So these are additional. I think we completed 7D. I think it is 7E. It must be. Oh, there are 1, 2 problems are remaining in the previous exercise. Okay, we'll solve. Okay, so this is 7F, exponential and logarithm graphs. So we did see. Okay. So this is 2 power x graph. This is 2 power x graph and it is log x graph. Please concentrate on these two. Log x graph and 2 power x. And these are the further restrictions, domain and range. Domain and range values of 2 power x, log x base 2, log x base 2, and how the asymptotes will work here, and vertical asymptotes, and increasing, decreasing, concave, up, down. So this is all character of the functions. The character of function e power x and log x base 2 or base 3 or whatever. Okay. So 1 functions with a vertical line test we can apply that 1 condition. And now we have to see different graphs. Okay, so what is this? If you know y is equals to e power x graph, then e power x or any number a power x, so you should know y is equals to a power minus x. So this is y is equals to 3 power x graph and its y-axis reflection is a power 3 power minus x is a graph of 3 power minus x. Similarly, so this is 3 power x, okay, and this is a graph of minus 3 power x. Okay, it is 3 power minus x is different, minus of 3 power x both are different. Okay, 3 power minus x is nothing but 1 upon 3 power x also you can take. So this is reflection about y-axis, and the sign, if you change the sign of the function, it is 3 power x to minus 3 power x. It is reflection of x-axis. Okay, so important. And similarly, so this is a graph of log x base 2, and this is a graph of log x minus 1 base 2. It moves a little bit forward. So when x goes to x minus 1, the graph move to one step forward. When x goes to x plus 1, the graph move to left side. Is it clear? In the parabola, in the in a quadratic equation, we learn about that. Okay. So whatever, if y is equals to f of x is a function, y is equals to f of x is a function. I'm just here. If y is equals to f of x is a function, then y is equals to f of x plus 1. It is the same graph of f of x but moves one step left. Okay, and f of x minus 1 moves to the one step right. Is it clear? And f of x plus 1 moves to up. F of x minus 1 moves to down. Sorry, it is f of x minus 1 moves to down. So it is moving a right because x become x minus 1. X become x minus 1. So it says that moves to rightward. It goes to right. They are the graphs we have to understand. And how many steps it been moved? How many steps it been moved up or down? Here it is up. So it is a graph of how many steps it is moved up? 3 steps. Therefore, it is the graph of log of x plus x base 2. 3 steps it moved for upward. 1, 2, 3. It is a 3 plus log x base 2 or log x base 2 plus 3. If it is minus 3 is there, then it gets down. Okay, so that's the basics. The word logarithm. So can you read this story, small story? Okay, okay. So that is calculation. And so what are these words? Two Greek words. One is logos. One is arithmos. Arithmos and logos. So logarithmos. Okay, logarithmos. Arithmetic. What is meant by arithmos? Means number. Arithmos means number. Do you know? He said that logos means ratio or calculation, and arithmos means number. And do you know my mother tongue? I'm asking a question to you. Do you know my mother tongue? I am from Telangana. Telugu, right? In Telugu, number means anke. 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 Okay. So in Telugu, I can write like this: A, M, Ka, K. So it is anke. Anke means number. Anke means number. So here a little bit similar, begin with same letter A. So that's why I said. So it is Arithmons means numbers. Ankelu. Ankelu means plural. Number means anke. It's a digits. Digits. We can say it is digits. Digits means ankelu. Number means sankhyalu. Okay. So it is amke and it is amke. It is k. And there is samkhya. Some kya. Okay. It is complicated, right? So that's numbers in a plural. Okay. So until invention of calculators, the routine method to performing default calculators in arithmetic was used to table. So we don't know the calculator, and we have to go with the tables. And logarithms invented by Napier to convert products to sums. So product is different. Okay, see why it is important. It is making the log of x y. It is a product of two numbers. Am I right? Log of xy is equals to, so we have log of x, log of x plus log of y. What we did is set to product xy, we are doing addition. Is it here? So the complexity of calculation will be reduced. So it is the most important to see. Product is product, but we are not doing product. We are doing addition. Addition is simpler. Okay, and quotients to become differences means the log of x by y is equals to log x minus log y. Clear? So this is the difference. And now, so it is a small story going by. Now 7F. So use calculator button log to complete the following table to calculate values to give the entry of correct two significant figures where it is appropriate. Log means what? Log means log base 10. Log means log base 10. So you can fill. And the plot the graph of log x base 10. Log x base 10. So after you getting, so these are the y values, these are the x values, x, y. So you can remember, you can recognize these points in the plane, and then you can draw the axis. Okay, it will go like that, like this. Okay, so it is a log. This is a one. Log one is zero. Log one is zero. Sketch the graph. Use a large scale with a small scale on both axes, with same scale on both axes. Same scale. Taking same scale is also most important in graphing. Ideally, use a graph paper so that you can see the shape of the graph. Copy and complete the two tables of the values. Copy and complete these two tables of values. So what is the first value? Can you fill these answers? 1 over 8, 1 over 4, 1 over 1, which is minus 1, which is minus, sorry, it is 1 only. It is 1 only. 1 over 1. It's something power 0 is, it's a 1 over 2, right? Thank you. It's a 1 over 2. And something power 0 always 1. It's a 2. It's a 2. Okay. And this is 4. This is 8. Okay. And this minus of minus. It goes to reverse. Can you see minus of 1 is plus 3? So it is 8, it is 4, it is 2, it is 1, so 1 over 2, 1 over 4, 1 over 8. Okay, so this is the case. Hence, sketch the graph of 2 power x. We can so it is the same graph. It is the same graph. We already seen in the previous sketch. Okay, we already seen that previous sketch is 2 power x and 2 power minus x. So the graphs will be like this. 2 power x will be like this. This is 2 power x. This is 2 power 0 is 1. Okay, and this is 2 power minus x. Clear? You should remember these graphs very carefully. See, these all graphs are just alphabets of mathematics. Okay, the alphabets of mathematics are not numbers. If you want to sit in a high position, means in the understanding of mathematics. So these basics. Okay, so this is B. You should plot all functions, all basic functions, and how are these two tables are related to each other? Related to each other means what? It is reflection about y-axis, which is reflections. And what is symmetry of symmetry? What symmetry does the graph display? Y-axis. Y-axis symmetricity. Okay. So whatever the graph, it's a symmetric. It's a symmetric about y-axis. So what are the domains of these functions? What are the domains of these two functions? You have very good. Negative infinity to infinite. This is entire real line. You can say it is negative infinity to infinite. Okay, so that is the case. Next, what is the range? Yes, greater than 0, and you can write like this: 0 to infinite. Okay, and the range is 0 to infinite. So what is the asymptotes for these two graphs? Which line is touching at infinity? X-axis. Both for the both graphs, it will be x-axis. Next, copy and complete. As extends to minus infinite, what 2 power x is going to? This is your x. Minus 1, minus 2, minus 3, minus 4, minus 5, dot, 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 dot. Minus infinite. Where is your y values are going? At x equals to 0, what is the y value? Is 1. At x equals to 0, y value is 1. At x equals to 1, y value is less than 1, 2, less than, smaller, smaller, smaller. The values are going down, 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 down. So while like you are going to extends to minus infinity, where your values are going? 0. You are going to minus infinite. Is it clear? You are going to minus infinite. So that's why your value is 0. As extends to plus infinite, where are you going? 1, 2, 3, 4. You have to give the values of y. Okay, this is 0 only. What about as extends to plus infinite? Infinite. You have to provide the values of y. What about x equals to 1? The value is 2 here. What about x equals to 2? The value is here. X equals to 3. The value is here. X equals to dot dot dot. You are going dot 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 to infinite. So is the value infinite. Is it clear? So it is infinite. As extends to minus infinite, where is 2 power minus x is going? Now you have to come to another graph. As extends to minus infinite. So where are you going? Infinite. Very good. Very good. It is infinite. As extends to infinite, where your 2 power minus x is going. 0. So this is actually y is equals to 0. This is uh, this is y is equals to 0. Entire line y equals to 0. This is y is equals to infinite. Okay. So it is 0. Copy and complete the table. So it is a similar example. Okay. So this is similar example, but he is asking about logarithms. You have to give the values of logarithms. Okay. And if you see here, if you see, okay, so if you see, this is a graph of log e power x 3x. E power, not e. We have to go for 3 power x. Okay. And this is a graph of log 3 base x. Log x base 3. Clear? Now please tell me, what is the domain of the 3 power x? Very good. Negative, infinite to infinite. What is the range? 0 to infinity. Very good. What about log x base 3? Domain is 0 to infinite. Very good. And 0 is open. It is not touching the graph. Very good. If you understand this kind of clearance, na, so you can do magic with mathematics. Okay. 0 to infinite, because the graph is defined only for the positive values of x. That's why log x, whenever you write, X is 0 to 1. Clear? So next, what is the range here? Yeah, negative infinite to infinite. That's it. Okay. And this is, you can know what is the asymptote of 3 power x. What is the asymptote of 3 power x? X-axis. What is the asymptote of log x? Y-axis. Very good. Y-axis. Copy. So this is, what is the G ion first one? First one? 0. Next one. Now your tending extends to 0. So you are on x-axis. This is your point 0. Reaching 0 from the right side. Okay. This is 0. So you are reaching 0 from the right side. Okay. So do you have the left side of the graph? Do you have the left graph? No, that's why he mentioned 0 plus means reaching 0, plus means from the right side. So as see here, it is 1. This is log 1. Okay. It is 1 by 2. The values are here. It is 1 by 3. Next, your values are getting down, getting down, getting down, getting down, getting down. What is this? It is y is equals to minus infinite. Means log x is goes to minus infinite. Is it clear? So sketch the graphs of 3 power x and 3 power minus x on one set of axes. You can plot 10 power x and 10 power minus x also. You can plot it easily. It's not an issue. Sketch the graphs of one set of axes means all graphs you have to plot in the same set. Can I plot the fifth one? So if you see, this is graph, this is graph, and 2 power x is this. Okay, 2 power x is this. 2 power, this is 2 power x, and this is 2 power minus x. Clear? I'm taking another graph, another image. So this is your no, I'm wrong. I'm wrong. I'm wrong. So this is 2 power x is done. 2 power minus x is done. Minus 2 power minus x is done. Oh, it is no. So this is 2 power minus x is done. What about minus 2 power x? It is 2 power x. Okay. Minus means all values get down. Get down. Okay. So this is minus 2 power x. Clear? And it's a reverse, means this 2 power minus x is there. It is minus 2 power minus x means this is above upside symmetric about y axis, x axis. It is minus 2 power minus x. Is this clear? This is plotting on the same set of axes. Next, can you plot uh, A? Plot and send me in one graph only, one set of axes. Mhm. Draw 2 power x. Okay. And then after that, 2 power x plus 3 means what? On the same graph, you have to plot these three. Before, let me check my live session is working fine or no. Yeah, it's a fine. It's working fine. Can you repeat? A only. 2 power x, graph 2 power x. Then make some suitable changes, left, up, down. Make numbers on x-axis, y-axis. Then only you can get it some clearly. So my total count of subscriptions become 91. This is 91. I have full-fledged student communication. Okay. So I will get easily 1000. Easily 1000 is easy, very easy. But after 1000, whatever becomes, it is on the spreading of my website only. So that's why I'm trying to make country names specifically. I should not search in India. I should search only in Canada. Because, in UK and in US, Canada, if you want to get the individual tuitions or personalized tuitions, one should sell their property. Such an highly expensive teaching is there. This application is quite comfortable. See here, lines are coming very clearly. Here I can draw each and anything by default, but it is working a little bit slow. Okay, I got it. Right, but a little bit sensitivity is most important. Okay, a little bit sensitivity means why I am telling the word sensitive, because the graphs are sensitive in their. I should add some image. Now I'm coming to your point. So, where is your zero? Zero at here, no? This is your zero. Where is your minus one? Where is your one? How much difference between zero to minus one and zero to one? Because they must be same. And 0 to 1 is okay. What about 1 to 3? How much distance should be 1 to 3 between 1 and 2? 1 and 3. Is it clear? So, if this is your x axis, this is your y axis, and this is your 0, this is your minus 1, minus 1. Why it is not getting? Okay. So this is your minus 1. Okay. This is your 0. This is 1. This is 2. And this is 3. Am I right? So your first graph must go like this. And moreover, see, it should not cross minus 2 below. Is it clear or no? This is your graph only. Okay. Am I right? And for 2 power x, this is your graph. For 3 power x, this is your 3. Your graph is this only. Is it clear? And it should not cross 2. Okay, so these are the changes, but your graphs are parallel. It's not parallel, all are going to plus infinite. This goes to up, this goes to up, this goes to up, all are goes to plus infinite. Okay, the only difference you can see here, the y-axis. Clear? Similarly, same thing with log x. Same thing with log x. So I'm taking this is your log x. Okay, base 2. And minus means negatives becomes positives, positives becomes negatives. Am I right? So this is your minus. Okay, log x base 2. Clear? And and log x base 2. And what about log minus x of base 2 of on the other side of y-axis? Symmetric about y-axis. Okay, on the other side of symmetrical as y-axis. So this will be your okay. This will be your log of minus x. Okay, and minus of log minus x is very good. Reflects about x-axis. So this is your reflects about x-axis. It is minus log of minus x base 2. Clear? So with one function, you can plot 4 graphs. Not 4, you can plot many graphs with numerical addition, multiplication, numerical addition subtractions with sign changes. Okay. And see, this is log x. It is lift up. The graph goes to 1 inch, 1 inch, 1 cent, 1 unit upside. The graph goes to 1 unit downside. Okay. The same graph, it is plus 2. It is a plus 2 for the minus log 2x. So minus log x base 2, 2 units goes to upward. 2 unit goes to downward with minus 2. Clear? Okay, good. So we have the logarithms. So we done. We done almost 7f is done. So there is a ninth problem. So this is a graph. The graph has been given. This is a graph of y is equals to 2 power x. Read the values from the graph. Use the graph to answer the question below, giving your answers correct to no more than 2 digits. Okay. Read these values from the graph. So where is 2 power 2? E power 2, 2 power 2. What is 2 power 2? So that is on the graph where it will be appear. This is a graph of, this is a graph of, what is this? Can you read the question? It is a graph of y is equals to 2 power x. Okay. So where 2 power 2 will stay? Where is your 2 power 2? When x is equals to 2. When x is equals to 2, then your y is equals to 2 power 2. Am I right? So this is when x is equals to 2. So where is your graph? So this is 2 power 2. So what is when x is equals to minus 2? It is minus 1. This is minus 2. So this is a 2 power minus 2. Clear? And what about 2 power 1.5? Where is 2 power 1.5? When x is equals to 1.5. When x is equal to 1 point. This is 2. Okay. 1.5 is, this is your value. 2 power 1.5. See, in the previous last 1 week onwards, we evaluated these kind of numbers only. 2 power 1.5. It is 2 power 10 by 15 by 10 and all and all and all. So with the graph, we can directly access what is the value of 2 power 1.5. It is 2, it's 2.5, 2.6, 2.7, 2.8. It is about to 2.8. Okay. So with the graphs, we can access these kind of complicated decimals, powers and all. So what about 2.04, 2 power 0.4? 2 power 0.4. So it is 0.5. Okay, 2.0.4. It is 0.5. Okay, it is 0.1, 2, 3, 4. So this is a value. 2 power 0.5. Clear? It is about to here. 1.45 something it is. 1.35. 1.35 to the 4 and then 5. Clear? What about 2 power minus 0.6? It's a 2 power minus 0, minus 0.5, minus 0.6. This is the value. 2 power 2 power minus 0.6. The value is about to here. 0.5, 0.65, 0.65. Clear? Find x from the graph. 2 power x is equals to 2. Where the function value is 2. This is 2. So what is x value? 1. X value is 1. So it's 1. So where the x value, 2 power x value is 3. Where very good 1.6. That's it. So where the value is 1.2. 2 now on x-axis look at 1.5, 1.2. On y-axis look at where is 1.2. This is 1.2. 0.2, I think we can say 0.25. It's a half. Okay, 0.25. Where is 0.4? Am I right? What is this number? Minus 1.3. Find the values of x where the graph lies between 1 and 4. So you will get some interval. Look at the graph. From which value of x the graph is lying between 0 to 4? The graph lying between 1 and 4, it must be. See, where is y? This is 1. Okay, this is 1. And this is 4. Provide for what values of x these values are 4 means. What's a 1 down here come? What's a 4 down come here? So from 0 to 2, your 2 power x graph lies between 1 to 4. Okay, and where 1 to 2, so this is a graph 2 up to here, it is 0 to 1. Okay, and where the values are lying between 1.5 to 3, please give me the answer. Where is 1.5? Here is 1.5. I'm taking another color. Where's the 1.5? This is 1.5. 1.5 to 3. There is a graph 3. Can you provide the answer? Very good. 0.55 x 0.55 to 1.6. 0.55 to 1.6. Okay. Where is 0.5 to 2? 0.5. This is 0.5. 0.5 is this. Okay. 2. This. So what is the x values? In between minus to 1 to 1, your value lies between 0.5 to 2. Am I right? Think this is 0.5, but graph is not here. Graph is at here. From here to 2 means here you are minus 1 to 1. Read the graph backwards to find log 4 base 2. Uh, log 4 base 2. But we can't get it directly. Just give me a second. Because he given the values of, how can we get log 4? It's actually 2, but how we got it? 2 power 2. This is e power x. What about log x graph? Ah, think carefully. You have to rotate the graph. All right. I'm taking. Let's do some magic. Okay. I'm taking. Can you see this graph? What happening? But is this a graph of log x? No. This is a graph of log x. I'm taking this graph to side. Okay. Is this clear? But no, this is not the graph of log x. Okay. So leave it about this. Leave it about this. You think it has to be moved a little bit right. Okay. We need to plot the graph. Read the back values of means inverse values. So, oh, okay, they are the inverse values, na? So at 4, when I want to get the answer. Okay, I'll read this case. I'll try to understand how to read these values. Okay. So next, sketch the each graph of this separately. So here x becomes x minus 2. x become x minus 2. Means what happening? What happens here in the 10a? It's right. It's not for minus stands for left. It's right. X is changing, not the entire function. Okay, it moves right. Okay, it is 2 power x and 2 power x minus 2. When you see, it's a Desmos graphing calculator. One is 2 power x. Another one is 2 power x minus 2. Move to left or right? The graph is moved to left or right? Hmm? When x goes to x minus 2, then the graph moves to right. Okay, it's a moves to right 2 units. What about this b? What about b? Moves to left 1 unit. What about c? Left moves to left 1 unit of log x graph. Okay, what about d? Moves to right 1 unit log x graph. And is okay, sketch the graphs and the separate axis. 2 power x plus 2 power minus x by 2, 2 power x plus 2 power minus x by 2. So we are adding two functions. Okay, so these are different. We can't capture easily. Okay, we are adding two function means we are adding two functional values. The graph could be vary. Okay, we can't get it easily. So you have to, can you see, you will see in the Desmos 2 power x plus 2 power minus x. So this is a graph of, sorry. So this is a graph of 2 power x minus 2 power minus x by 2. And this is a plus of 2 power x plus 2 power minus x by 2. Can you see? We can't predict these kind of equations. We can't predict the addition of two means after a big practice you can, but in the basical way, so we can't predict how the graph goes to. We can say when x changes to its addition of product, addition of subtraction of constants, or the f of x changes by the function, then it changes by the plus minus 2 or plus minus constant, then only we can predict the values. Okay, so now this 7g application of these functions. Okay, is it clear? Okay, so let's take a little bit break, but I think you said 1 to 2. Can I continue? Okay, so let's take a 10 minutes break and I will back in 10 minutes. Okay. I'm stopping. So we will continue in the next session. So almost 50 minutes been recorded. Thank you.